Hey everybody, ABC 10 meteorologist Brenden Mincheff here. It is a new weekend, time for another look at how we're doing with drought, and I'm going to touch on something we haven't really talked about for a while. That'd be wildfire. We'll come back to that in just a minute. Let's recap January real quick because we actually saw a really nice bit of rain in January. In fact, over 7.5 inches was the final monthly total for January 2023. This is at downtown Sacramento. The average is about 3.9 inches, way above that for the month of January. Our rainiest day downtown Sacramento was January 9th. We saw 1.32 inches of rain, but there were several days where we saw just about an inch or a little more, such as January 5th, January 14th as well. A nice rainy start to the month, kind of, in fact, maybe too much rain all at once, but we got the rain and it really helped us out with the drought. February, only a few days old at this point. We've seen a quarter of an inch of rain already at downtown Sacramento. Average to date is about a half an inch, so we are behind for the month. But again, the month has just started, and this does not take into account anything that has fallen today as of February 5th. So these numbers here, again, about a quarter of an inch. We've seen a little bit more in downtown Sacramento already today. So these numbers don't quite reflect that yet. For the water year, started October 1st, still doing pretty well. In fact, about 8 inches above where we normally are. Total to date, 18.47. Average to date, 10.58, which means we are, again, about 7.9 inches above the average for this time of year. Not just here in Sacramento, but across the state. We're doing pretty well in terms of rainfall. Everywhere that you see here, that's what we've seen so far since October 1st, and this is how we're doing compared to average. Everywhere in blue now is above average. The only area, major city I should say, that is below average is Palm Springs, about a half an inch below where they normally would be to this point in the water year. But San Diego, LA, Santa Barbara, Bakersfield, Fresno, Stockton, San Francisco, Sacramento, South Lake Tahoe, Redding, and even Eureka, just barely, is above average to this point in the water year. And our snowpack is doing phenomenal right now. Let's talk about January 1st. So what we saw in January, not the day January 1st, but what we saw in January: Kirkwood, 215 inches of snow fell in January. Sierra at Tahoe, 190 inches. Bear Valley, 188. 179 inches at Sugar Bowl and 172 inches at Palisades, Tahoe. That means for the season, Kirkwood has seen 380 inches, which is 173% of the average season to date. Sierra at Tahoe, 370 inches, 181% of the average to date. Bear Valley, 217% of the average to date with the 350 inches that has fallen. Again, this is since October 1st. 362 inches so far this season at Sugar Bowl, 370 inches at Palisades, Tahoe. And again, both of those are quite a bit above average for this point in the year as well. 158% and 154% respectively for Sugar Bowl and Palisades, Tahoe. So the snowpack as a whole is above average, not only for the season to date, but also for the percent of April 1st average, which we've talked about a lot lately. That's the number to watch, and that's the number that's doing very well right now. 106% in the Northern Sierra of April 1st average, 132% in the Central Sierra, 153% of the April 1st average in the Southern Sierra. So statewide, 202% snowpack average to date, 129% of the April 1st average. If you've been following along over the last few weeks, you've probably noticed this number keeps going down a little bit, but this number keeps going up. That makes sense. As we get closer to April, you would expect that we see more snow falling. So the average to date goes down, but the percent of April 1st average keeps going up because we're getting closer to April 1st. So as we keep that snowpack and get closer to April, this number should continue to go up a little bit. And of course, we're still seeing snow falling right now. For instance, we are seeing some falling over Saturday night and today as I'm filming this, which means those numbers will not even be factored into this until we get towards Monday. In terms of the drought, no change from last weekend's drought monitor. So the map looks exactly the same. 0.64% of the state is not in any drought at all. That is way up here in the far northwestern corner of the state. 9.80%, roughly 10% of the state, is in the yellow color, the abnormally dry color. Most of that is the Central Coast there. Moderate drought is more than half the state. 56.99% of the state is in that kind of tan color, that moderate drought color. Sacramento is in the severe drought category still at 32.57%. No change in the extreme and exceptional, which is good news because none of the state is in that category. All right, shifting gears just a little bit now. There are some big wildfires ongoing in the country of Chile right now. More than 200 active fires with over 100,000 acres burned. more than 900 people have been injured and at least 23 people have died as a result of these wildfires. It's all part of a blistering heat wave that's going on down there. Temperatures are 90 degrees Fahrenheit or warmer, and that may not sound all that warm, but for Chile, the averages for this time of year where the fires are burning, the averages are in the low to middle 80s down there. Remember, it's summertime in the southern hemisphere, so these temperatures you would expect to be much hotter than what we see here, but still, averages are about 10 degrees or more above average, with more heat coming through the first half of this week. In fact, 76 new fires started on Friday. 16 more started this past Saturday. So a lot of fires are starting. Not all of them are very large fires necessarily, but the problem is more of these fires keep popping up. Because of that, Argentina, Brazil, and Spain are sending crews to go assist. It's all part of that heat wave like I talked about. There's a lot of wind going down there too. But there's also a non-weather factor at play, and that's that there's been a lot of non-native plants, such as eucalyptus trees, which are used for farming down there. And those non-native trees, which are densely packed onto farmlands, those are allowing for some rapid growth of these fires down there. So again, it is weather related because of the heat and the wind, but also when you talk about the trees that have been planted, the non-native ones, eucalyptus specifically, it makes things a lot worse. But that made me think about how things are going down here, right? Because when we take a look at Chile and you see the satellite, you can see the brown up here that's going around this high pressure system, and the smoke is coming from right here in the kind of southern to central part of the country. That's where all those fires are, and it's getting pushed off around the high pressure. So that made me think, what about how are we doing here in California, right? We talk a lot about wildfire more in the summer and fall and not so much in the wintertime, but with all the rain, surely things have to be looking a little better, right? Well, in fact, they are. So I'm going to show you the energy release component, both for the valley and foothills and then for the Sierra. The energy release component, or the ERC, is basically a measure of how moist the fuels are. So this takes into account your 100-hour and your 1,000-hour fuels, both live and dead as well. So the lower the number, the better. That means there's less energy to be released. There's less heat to burn, less things to burn in general. So for the valley and foothills, we're doing pretty good. We're right about average. The gray line here is your average line. The blue line is where we're at right now, and the red line is your max. That's kind of the worst case scenario. And you can see we're doing pretty good. That number is coming back down again, right about 18% or so. This is for the valley and foothills. Again, that is a good number to have. And anytime we get rain and we get snow and we stay cooler and stay wetter, that helps bring the ERC down. That's that moisture content. It's all related to the moisture of the fuels. As we take a look at the Sierra, we're also doing well. In fact, we're doing better than average in the Sierra. Again, red line is your max, your gray line is your average, and this is over time, right? So this is the start of the calendar year, and then we're working through summer, fall, and then back towards, this would be December 31st of 2023. So if we zoom in now, you can see that number, again, a very small number, less than 5%. The average is a little less than 10%. So we're doing well in the Sierra too. The fuels are wet, which means there is not as much energy to be released. Now, this is going to change, obviously, because we're going to warm up, we're going to dry out. I'm not saying it's going to stay this way by any means, but I am saying just kind of checking in on things. We're doing pretty well right now, both in terms of, the drought, moisture content, snowpack, and of course, when it comes to our fuels, it's helping that as well. So as we work through the next several months, this number is very likely going to go up as we go through March, as we go through April. We're very likely not going to continue to see rain event after rain event after rain event like what we saw in January, which really helped to drive those numbers down. So as things warm up and we don't get quite as much rain, as consistently over the next several months, that number will go up. And I'm sure when we get back to the summertime, depending on how things go, depending on how the snowpack plays out, it's still a little early to say, but we could very well be back towards average or even above average in terms of the energy release component by the time we get to summer and fall. We'll just have to keep an eye on things. But continuing with the theme of wildfires this week, UC Davis released a study just recently that said wildfires are getting worse. Perhaps no surprise, we kind of already knew that, but it's due to a lot of things, such as climate change. It's due to things like warming temperatures, drier droughts, right? Longer droughts, more severe droughts. It's also due, though, to fuel management. And honestly, over the last 100 years, we've not been very good about managing our forests and managing the fuels up there. For instance, really, the 20th century policy was don't let anything burn, right? If a fire starts, we got to put it out. We got to put it out immediately, as fast as possible. There wasn't a lot of prescribed burns that happened over the last 100 years. But some scientists with UC Berkeley are actually studying the effects of prescribed burns and different ways to manage fuels, both using prescribed burns and without. This is all happening at the Blodgett Experimental Forest, just up the road in the Sierra. This is near Georgetown. And a few months ago, this was back in October actually, they invited some journalists up there, and I went up there because the mosquito fire burned through a portion of the Blodgett Forest, and that really gave them a real-world test of how some of their fuel management practices work. Check it out.
Basically, we have 100% mortality in this structure over here.
Outside of Georgetown lies the Blodgett Experimental Forest.
It's a really great place to come and talk about a couple different forest structures and how they responded to the wildfire.
This past September, the mosquito fire burned through a portion of Blodgett, where UC Berkeley researchers were eager to see the aftermath.
The wildfire hit this type of a structure. It behaved in a very kind of high-intensity manner. And we really hadn't done a whole lot out there. So we've had 20, 30 years of time for fuel to accumulate on the ground here. We haven't done anything to treat the fuels on site.
Burning through this section of forest, called a stand, the mosquito fire killed everything from the floor to the canopy. But when it hit a different stand, one that had been managed via harvesting and prescribed burn, the fire behavior changed.
But we did see the fire effects change. It still killed some of these trees along the edge, but it did then drop to the ground, and it became, we're assuming, more of a surface fire, and we didn't have the same levels of mortality. And then ultimately, this is where they were able to put containment line in, is to this area that we had treated with prescribed fire.
We talk a lot about fuel dryness, but that is only one aspect of fire danger and fire behavior. The different types of fuels and how they are managed also matter. There are 3 primary types of fuel. There are the canopy fuels, which are the very tops of trees. Ladder fuels, such as small to moderate-sized trees and lower branches of larger trees. Then there's the surface fuels.
That's your needles, needles that have fallen. That's branches that have fallen. That's shrubs. That's small trees. That's what we consider surface fuel.
So much goes into fire behavior, including winds, fuels, and topography. So can we say the change in fire behavior was exclusively due to better fuel management?
So we can't really say with certainty, but we have to put these pieces together after the fact, looking at both the effects of the fire, knowing the history of the stand and the fuel conditions. So I think we can say with pretty good confidence that the fuel conditions really dictated that.
Yeah, I think the surface fuel is what we're seeing is really, really key. Treating that surface fuel, anything that we can do, which really fire is the only way you're going to remove that surface fuel, but doing anything to treat the surface fuel is going to have an impact on fire effects.
Young, crowded stands like this one the mosquito fire burned through are common sights on industrial land, and it's even difficult to do a prescribed burn through young stands like this. But doing nothing, it's a high-risk, high-reward situation because it can cost upwards of $1,500 an acre to clear non-valuable trees with no return.
Obviously, it's a problem from a fire risk standpoint, but it's also a problem of what we can do with that. We don't have a lot of options without spending tons and tons of money. So in a way, you kind of look at this as just kind of biding your time, like, gambling a little bit, knowing it's a very vulnerable condition, but the cost of trying to mitigate that is just too high.
And that's only on industrial land. Federal, Forest Service, and national park lands are even tougher because the issue of burning and/or commercially removing trees is a controversial topic.
But there's tons of land, a lot of Forest Service land, et cetera, where there are trees big enough that can help pay for the restoration, but we have to be okay with harvesting and processing lumber, and that sometimes can be controversial, and people don't want to think about on public lands, like using our lands that way. But I think there are ways to do it, so what I would say, like, responsibly with even a conservation and restoration bent.
Still, it's more than just funding. Oftentimes, it's an infrastructure and personnel issue too. What would you do with all of this non-valuable lumber?
Funding is a huge piece of the puzzle, but it's not the only thing. It's also where the funding goes, right? It's not just giving a landowner, like, you could give me all the money in the world, and there are certain things I could not do here because the infrastructure doesn't exist to do it and the workforce doesn't exist to do it.
To a certain extent, though, the funding the state has been able to put forth over the last few years has changed that a bit. People are through grants, which is kind of an onerous process. I think even applying for the grants, once you get it, it can really help. the question is at what scale? I mean, can we as taxpayers fund that like over the many millions of acres that need it?